we're making sure our polynomials are in descending order. So start with the highest exponent, go down, make sure it's in that order. And then we're looking for a greatest common factor across the entire problem. Okay. Sometimes there's one, sometimes there's not. Okay. We encountered that. Every one of them we were doing the last couple of days has been, it had a GCF. That's all we were looking for. With this, we're looking across the entire problem to get a GCF out first, and then we have to do something else after that, okay? So we're looking for a greatest common factor across the entire problem, and then the third thing, this is the new step, is we want to count the terms. Today, every one of them you're going to do is going to have 4 terms. If it has 4 terms, that means it's got 4 pieces separated by addition and subtraction. You got 4 pieces out of that. After you pull the GCF out, set that over to the side, and then look at the 4 terms that are left. The method that we're going to be using is grouping. And I'm going to show you how to do that. Grouping is just doing greatest common factor more than once. That's what grouping is. So it's still doing greatest common factor, but of a smaller part of the problem. So it's kind of like taking the problem and cutting it in half, doing GCF of the first half, GCF of the second half, and then working the final result. So I'm going to show you how to do that. It's really, if you understand greatest common factor, grouping is really pretty easy, okay? So 4 terms, we're going to do grouping. As we progress here, we'll get to things that have 3 terms, and we'll do this thing called the X method. And then there's 2 terms. We'll do this thing called difference of squares. Today, all we're doing is grouping. That's the only thing we're doing today. So nothing else, you know, this other part is stuff we'll get to. Next week, probably. Okay. So counting terms, 4 terms. We're going to do grouping, and everything we're seeing today is going to be factoring by grouping. So let's look at an example, and it just says factor completely. Factor completely. That just means look for GCFs if there are any, and then follow the rules about factoring by grouping if that's what the case is, and that's going to be the case today. So x cubed plus 5x squared plus 6x plus 30, okay? So here we have a polynomial that's got 4 terms in it. Is it in the right order? No. Okay, biggest exponent is what? The 3, the x cubed. All right, is it in the front? All right, then we go down from there. So it's x squared right after it. Then plain x. Then the number doesn't even have a letter. So it is in the right order. That is descending order. So it's going by the exponent that's on the variable, not the number in front. The exponent on it. All right. Now, so that's in the right order. The next thing we look for is the greatest common factor across the entire problem. So all 4 pieces have to be divisible by it or have it. So this has got a 1 in front of it, 1, 5, 6, and 30. Is there anything that goes into all 4 of those numbers besides 1? No, there's not. If it were just 6 and 30, there's a GCF between those. If it's just these first 3, they all have an X, but that 4th one doesn't have one. So there's not a common factor across all 4 of them. So there's not a GCF to this problem. There, it gets us to the step about grouping. So we got 4 pieces, 1, 2, 3, 4. What we're going to do is we're going to separate the problem into 2 halves. If you take half something, it's 2 pieces of it, right? We're going to take the first half, and we're going to put it in parentheses. And we're going to work the GCF of the first half. What's the GCF of this first half? X squared, good. What's that leave in the parentheses? What times x squared would get me x cubed? X, what times x squared would get me a plus 5x squared? Plus 5. We've factored the GCF out of the first half. The next thing to do is look at the second half. And I'm just going to underline it just to say I'm looking at this half now, the underlined part. We've already done the parentheses part. Let's do the underlined part. What do positive 6x and positive 30 have in common? What numbers go into those? 3 goes into both of them. And 6 goes into both of them. Which one's bigger? 6. So greatest common factor here is going to be 6 between those two. Because it's a plus 6 right here, we're going to pull out a positive 6. So I'm going to do that by doing plus 6 and then a set of parentheses. So this part right here doesn't even matter. The x squared parentheses x plus 5. Right now it doesn't matter. We're not even working with it. We're just working with this part. What times 6 will give me 6x? An x. And what times 6 will give me 30? 5. Notice those two match, right? That means we did it right. Okay, that means it's going to factor a little further from there. Now, the last step is to get your factored form, the last step. The last step, what do this piece and this piece have in common? They both have this x plus 5, don't they? Both have that parentheses the same. So technically, the GCF of this part and this part is x plus 5, that whole parentheses set. We can take that and pull it off of both of them. The final answer is you got your matching piece, x plus 5, that's what matches. And then the stuff in front, x squared plus 6. That's the part that's in the front. That's the factored form for that one. The matching piece, that's here. And then the stuff in front, x squared plus 6. Okay, and that's this second factor. Each parentheses is called a factor of that. If you did distributive property for this problem, like this, took this, x times x squared, we get x cubed. X times 6, that's 6x. 5 times x squared, that's 5x squared. 5 times 6, that's the 30. We get all those pieces back if we remultiply that out. So that means that worked for factoring that original polynomial. Let's look at another one. This just takes a little bit of practice and you can get there. So 2x cubed minus 10x squared minus 3x plus 15. Okay. Is it in the right order? Cubed, squared, plane, no variable. Right order. Okay. Next thing to do is group the first half together. Okay. What's the first half? It's these first two terms. 2 is what GCF. What else do they have in common? 5 doesn't go into 2. 2's the number. Both of them have x's. How many of them? 2. So the GCF would be 2x squared. What's left in the parentheses? What times 2x squared gets me 2x cubed? Just an x. 2x squared times x is 2x cubed, right? What times 2x squared gets me negative 10x squared? Negative 5. Good job. All right, so we factored the first half. Let's go and underline this and factor the second half. If we cover this up, it becomes a problem like we did in the last 2 days. GCF of negative 3x plus 15. 3, but the leading term is what? It's negative, right? So when we got a negative on the front, we want to pull that negative out with it. So let's pull a negative 3. And then what's that? What times negative 3 gets me negative 3x? X. What times negative 3 would get me a positive 15? Negative 5. Notice these parentheses. What's happening with them? They're the same, right? That means we did it right. Okay. Now, last step. Get the matching one. X minus 5. And then the second factor is the stuff in front. 2x squared minus 3. GCF is all we're doing, really. It's just GCF some more. And if we multiply this back out, 2x squared times x is 2x cubed. Negative 5 times 2x squared is negative 10x squared. X times negative 3 is negative 3x. Negative 5 times negative 3 is positive 15. It works there.
Will we ever have the answers that are not the same, like those two numbers are not the same?
You're talking about this part's not the same? If you do, then you either didn't get out the right GCF or it won't factor. Period. So yes, it can happen that way, but usually it's going, like today, it's probably going to mean you didn't get out the right GCF. That's as we're learning how to do it today. But as we get a little further, you will see that happening. Good question. Let's do another one. Let's say 9x cubed minus 6x squared plus 15x minus 10. Okay. So similar problem. It looks a little different because look at our first three numbers.
They all had X.
They all got X's and they're all divisible by 3. But the 10 on the end, is it divisible by 3? No, so we can't use a 3 as a GCF. And the 10 doesn't have an X. So there's not a GCF across the whole thing. Is it in the right order though?
Yes.
Yeah, if it's in the right order, then we can work with it. So we want to take the first half and get the GCF of it. So first half, GCF of 9x to the third and 6x squared. 3 is the number, that's right. Well, how many x's? This one's got 3, this one has 2, so they got 2 in common. What's that leave in the parentheses? What times 3x squared gets me 9x cubed? 3x. 3 times 3 gets me the 9. X squared times x would be x cubed. So that's why it's 3x. 3 times a negative 2 would be 6. So it's a minus 2. Do we need any more x's? No, because we got x squared out here, and that's all that was there. Okay, so there's the factoring of the first half. Do the second half. Positive 15x minus 10. 15 and 10, what do they have in common? 5 goes into both of them. Is that the biggest thing? Well, 5 times 3 is 15. The only thing other than bigger than that goes into 15 is 15, but we know 15 doesn't go into 10. So 5 is the biggest one. What kind of 5 are we pulling out? Positive. Look at the sign that's right there. Whatever that sign is right there, when you got it in descending order, that'll be the sign that's right there every time. That never changes. That's always the same. Okay? So pull a 5 out. Do they have any x's in common? No, this one's got an x, but that guy doesn't. So we can't pull an x. Parentheses. What times this 5 gets me 15x? 3x. What times this 5 gets me the negative 10? Negative 2. Because we pulled out the right GCF and it's going to factor, the parentheses match. This goes back to what Ty was asking. Well, are they always going to match? If things are, if it will factor and you have pulled out the correct GCF, then yes. Okay. So final answer. You got 2 sets of parentheses that you should have. What's the first one? 3x minus 2. It's the one that matches. The second one, squared plus 5. One of them is the matching piece. The other one is the stuff that's in front. That's the factored form for that polynomial. Okay. So it's not. It's if you can do GCF, you can do grouping. And if you can do grouping, you'll be able to do the X method. And then the difference of squares is kind of its own thing. Okay. So it's all stacks on top of one another here. So that's why I'm kind of a little bit on the crazy side about trying to get you to do GCF, because I know you can do it. You're smart enough, And if you can do GCF, this part's easy. So let's do another one. Let's say we had negative 25 x cubed minus 5x squared minus 50x minus 10. Okay, a little bit bigger numbers, but think about descending order first. Is it in descending order?
Yes.
Yes. What's the next thing I look for? A GCF across the entire problem. Before I group it, I got to look for that first, because that doesn't happen very often, but if it does, we've got to take care of it. Okay, so what goes into all four of these pieces? 5 goes into 25, 5 goes into itself, 5 goes into 50, and 5 does go into 10. So 5 is the biggest one that goes into all four of them. Because this is a negative 25, what kind of 5 are we going to pull out? A negative 5. Okay? So we're going to pull a negative 5 as our GCF for the entire problem. So that's going to be a little tricky, but all it does is changes the sign of everybody. So instead of minus signs in front of these, we're going to turn them all into plus signs, right? Is what dividing by negative 5 would do. So then I'm going to use a bracket. Just to, brackets and parentheses are the same thing. If you want to use a big parenthesis, that's fine. I'm just using a bracket because I think it looks better. Okay? What times negative 5 gets me negative 25 x cubed? Positive 5 x cubed. What times negative 5 would give me a negative 5x squared? Positive 1 x squared. And then we would have a positive 10x and then a positive 2. Okay. So we've taken the 5 out. If we distributed this negative 5 back out to this stuff, we'd end up with the original. Okay, so we've done the first step, getting the GCF of the entire problem. The next step is to take what's left in the bracket here and do our grouping with it, because it has how many terms? 4. It's got 4 terms. This negative 5 that's out in front, it's just kind of watching what's going on. It's just sitting on the sideline waiting for the end, and it's going to stand there by the trophy when we get it. Yeah. It's kind of like the backup quarterback for Tom Brady. He's not going to do much on Super Bowl Sunday. All right, so it's in the right order. We've already established that, so we can start grouping. First 2 together. What do those 2 have in common? 2 x's, so that'd be x squared. What's that going to leave in their parentheses? 5x plus If I pull an x, what's in front of this x squared? It's a 1, so there's a 1 left out there. All right. Second half. 10x plus 2. What'll go into both of those? 2. 2 goes into 10, 2 goes into itself. What kind of 2 is that going to be? A plus or a minus? What sign is right here? Plus. That's always going to match right there. That middle, the sign that's in the middle of the problem will always be in the middle of the problem. Okay? So a 2, parentheses, what times this positive 2 gets me positive 10x? Positive 5x. What times 2 will give me the 2 back? A 1. Do those parentheses match? Yes, that means it factored. It means we did it right. So the factors that go with that, got the matching piece, 5x plus 1. And then we have the stuff in front, x squared plus 2. Don't forget, we pulled out a GCF at the very beginning, that negative 5 that was hanging out, waiting for the end. Okay, that is the factored form for the original polynomial. If you multiplied all this back out together, you should be able to get back to here. That's the checking thing. You know, we did all the operations multiplying polynomials back before the Great Flood, and we did all that multiplication. Well, now we're undoing all that multiplication, so we should be able to check by multiplying if we wanted to make sure we had that correct. Okay, factoring by grouping does not get any harder than that. It really is. That the things that we've done on these 4 examples are the exact same things you're going to do on the practice for this. It's the exact same things you're going to do on quiz or test. If it's got 4 terms, you're going to factor it by grouping. It really is that straightforward and that easy. Okay, so got some practice here. I've got the answer key already posted here.